I'm David Kingham. I'm Executive Vice Chairman of Tokamak Energy, a company that started about 10 years ago. We are a spin-out of Culham Centre for Fusion Energy based near Oxford, and the technology we're developing is for fusion energy. So we are trying to make a major change to the shape of the future energy supply by developing fusion power in compact modular systems. Our USP is that we're using high temperature superconducting magnets to achieve very strong magnetic fields in tokamak devices, which are well known for their ability to control fusion reactions. So the best performing tokamaks in the world have achieved 10 megawatts or more of fusion power. We're not there yet, but our technology is much more compact. So primarily that's because of use of high temperature superconductors, but we also use the spherical tokamak as pioneered at Culham Laboratory as a more efficient shape of the tokamak device. So instead of the conventional donut-shaped tokamak, we're now looking at something that's much more like a cored apple, very tightly controlled plasma. And the challenge is essentially around the engineering of the magnets and then the engineering of the whole of the rest of the tokamak system. So the goal is to supply electricity or to supply heat for industrial processes or for processes like production of hydrogen. So the proposition, for example, to an oil company is in the 2030s, instead of digging wells for oil or gas, you actually build one of these devices and use the heat from the device to produce hydrogen or hydrocarbons from water and or CO2. So that it's a long way off. We've got a long path to travel, but the end goal is extremely attractive. So we're 10 years into the company's journey. We've built 3 prototype devices, prototype tokamaks, and we've achieved plasma temperatures hotter than the center of the sun in our 3rd prototype. We've also developed a major prototype high temperature superconducting magnet that's achieved magnetic field strengths of over 24 Tesla. Now this compares to 12 Tesla, which is the magnetic field planned in the ITER tokamak in southern France, which is costing around 20 billion euros. And again, our basic proposition is if you can increase the field strength, you can reduce the size of the device, and hence it is a lot cheaper, a lot quicker to develop, and a lot more efficient in final operation. So the milestones ahead are to get the plasma temperature up to 100 million degrees, and then to steadily increase the pressure in the plasma and a parameter known as energy confinement time, how long the plasma stays hot without needing too much external heating. The 100 million degree target is within the next year. We've obviously been slowed down a bit by the COVID crisis, but progress is still very good, and our basic plans have remained unchanged. The final goal, this is a very big opportunity. We've raised £100 million, over £100 million of private investment so far. We expect to raise a lot more, at least twice as much more private investment. There may then be an opportunity for a public market IPO or it may be best to raise further private capital. We think that strategic investors will start to come on board. It's been mainly private individuals who've invested so far. We think strategic investors will come on board, and at some stage they may get very interested indeed. The Bessemer Society is very helpful to me because it's a network of like-minded people tackling similar hard tech challenges. And the UK is not a bad place for people tackling such challenges, but it's not as good as the States, and it could be a lot better. And I hope it will indeed be a lot better in future, because hard tech companies, Bessemer Society members, are going to create the economic impact, the wealth, and the jobs in the future.